So let's start off with the homework. So I was looking through all your comments and reflections, and I thought they were all really good. Does anyone want to share theirs in particular? Anyone? Can you see them here?
Okay, I could start off.
Okay, thank you, Usha.
No problem. See, I watched the 6 short videos and all of them were pretty good. I kind of enjoyed them all. And it was something I'd use in my classroom for sure because they're very short and very informative to the point. So
Yeah.
those were good. And then most of them talked about the research they've been doing at Berkeley or at, I think it's UPenn, if I'm not, and maybe Penn State or UPenn. I'm not very, I forget, and Caltech. So these are the big institutes. Looks like most of the research is happening at the big places. Not too many small schools are doing much research, but. And then they talked about the properties of these nanoparticles, how they're trying to make it more smaller and how when they become smaller, the properties of the material totally change, and how they're trying to harness those properties to come up with useful things. And one of the most fascinating things which I found was they're trying to find these materials so they can make these cars and planes invisible.
Yeah.
I was like, wow, that's going to be rough, so, but something. So that's it. Thank you.
Yeah, that's great. Thank you. Yeah. So the series of videos, they have all sorts of different types of nano materials that they're developing. One is like the quantum dots. The other one are different devices. And then the other one is these, what they're calling meta materials, which are basically man-made materials. So they're using nanoscale, like nanoparticles to sort of put them into place, which then have an interesting effect when it comes to interplaying with like visible light, and so they can deflect it and basically be invisible either to the naked eye, or typically it's for like radar, so it's more for stealth. Does anyone else want to go? A lot of you had a lot of interesting things to say, so
I'll go. I just
okay,
have
thanks,
something quick to say that when I was watching the videos yesterday, I was kind of confused about the whole lithography and what lithography has to do with nanoscience. And my team did when we were talking about it. We're like, where's the connection?
Okay.
But the video helped me to understand.
Good. Yeah. Good.
Like,
yeah.
Maybe I was thinking about my lesson plan, and I thought that one of the first videos I watched, I think I would show that first to tie into the lithography lesson. So they were very helpful and very interesting.
Okay, good. Yeah. Did anyone like Stephen Fry's video where he's the narrator? I think he's a really good, I guess narrator is the word, but yeah. Oh, go ahead, Leo.
Oh no, sorry. I was just gonna ask Vicky a question.
Oh yeah, go ahead.
I was just gonna ask what was that connect that you found? Because maybe I didn't watch the same video.
It was the first of the short series. The first was one of the short series, and it explained how scientists take a picture or make a stencil, and so like we're looking at an atom, and they're able to really look at an atom. I guess it would be considered from the bottom up, right? Because it's a small atom, but then they're making it big to look at it. So I was thinking, oh, that's why lithography would be so important, so you can see things at a different scale.
That's great. Thank you.
Thank you.
Oh, okay. Yes, this one.
That one.
This one I think is a helpful one too, Vicky. The nano electronics one that really helps sort of connect all the different aspects, because basically you take that big wafer, you cut it up, or you don't just cut it up, but you pattern it using the lithography method, and then eventually it gets chopped up into like little microchips. But it takes 20 or 30 different processes just to get that done. Yeah.
I didn't watch that one, but I will now.
No worries. Yeah. Okay. Anybody else? Did anyone watch the strange one? I think some people did.
I just wanted to add a little bit to the nanoscience. I think it's extremely useful because we understand now how things are made. We see in depth that the small particles, once we understand something, we can rearrange them, we can make new things, we can modify it. So this nanoscience, I think it's a great thing. And actually the medical field, in engineering, in chemistry, physics, I think in all aspects. So it's a wonderful thing. I was amazed to see all this little thing. And, you know, we go to the atomic level and we even go beyond that, and how these things are arranged and how they work. And now, since we understand it, we can change it to our advantage, and, you know, we can make new things. So yes, it is great.
Great, thank you. Yeah. All right. Anyone else want to add a few more comments?
Wanted to comment on the fact that Stephen Fry's video kind of echoed all the sentiments that you've kind of walked us through these last couple of days.
Sure.
He kind of echoed all the aspects of biomimetics and also how nanotechnology is kind of like a reverse engineering of what nature has implored.
Right.
And we are actually just understanding all of those concepts so that we can use and adapt those properties and harness that type of energy and physical properties so that we can make our lives more, versatile.
Yeah, that's great. Thank you. All right. All right. Well, I'm going to move on. If anyone has any other comments, feel free to put them on the homework, and then also comment in the chat box as well. But I'm going to move over to our Gacha Needs. We are in day 3 already, which is just a real blur, which I think is a good and a bad thing, right? But I wanted to sort of go over some of the stuff. So, right, we got to see the tour of the clean room, and you saw a few characters that I work with who I really love. They're really awesome. You also got the sweet self-assembly, which is a really nice hands-on activity to demonstrate how medicines can be delivered to different body parts. And this particular teacher had a medical detectives class on cancer. So I think that's a really nice fit. It sounds good. And then we have a few needs and or questions. So I'm going to try to do my best to accommodate for all of this. So I think more time to share in our small group discussions. Yeah, I want to try to keep doing that a little more, but at the same time, we are so limited with our time. I don't want to ask more of you by just, being trapped during your kind of summer vacation to sit here any longer than 4 hours. So I would say if you have a lesson mate or a teammate that you would want to chat with, I obviously over lunchtime, I leave the group open. So if you want to be put into a breakout room, I would be happy to do that. So if you want to spend that lunch hour, mostly because that lunch hour also, we used to have teachers, we provided lunch and we would have them, sit and chat, and, there's, not a lot of that going on, or it's hard to mimic that. But if you do want to get to know someone a little longer, like feel free to put in the chat box, and you can privately chat as well. So please feel free to do that. I just, unfortunately right now, this is kind of what we're limited to, and I just don't want to extend and ask more of you at this point. Someone would also like more direction with the lesson plan. Not really sure if this is a bigger unit or just one lesson plan. So for the stipend itself, you just need to implement one lesson. But I think depending on what you want to do, you can do one lesson or a unit or a whole storyline on it. And so later today, Krithika and Jenny are kind of go over what they did in their classrooms. So Krithika did, I believe, a unit, or a small unit, I guess. It was a couple of lessons, but then Jenny did a full unit where it was many, many lessons. So Jenny had 64 slides initially, and has since cut them down. But so you'll kind of get a good sense of a smaller version and a bigger version and what you can do. So you can sort of decide what would best fit your classroom. Like, I guess for logistical sake, the bare minimum is just doing one of these activities in your classroom. Okay. All right. I hope that answers your question. And then if you're wondering, you can take our students into the clean room. So you're definitely welcome to come onto campus when we're allowed to have more people or visitors on campus. However, you cannot actually go inside the clean room. But if you're a teacher, you can come inside the clean room and we can do that video chat that we did yesterday, and the teacher can come inside the clean room. It's just that students under 18 and below cannot, because it's a big liability. It's really unsafe and things like that. So we can still do that kind of hybrid remote tour, because we can also take you and do sort of a walking tour around Stanford. So if that's something of interest, I can definitely accommodate for that, obviously pending the pandemic. Okay. All right, and then a little more time for the labs and explanations. Yeah, that is also a big challenge. I was trying to sort of get you to do the material prep, but also at the same time, yesterday was probably the hardest day when it comes to activity. So right now, today and tomorrow, we're really going to focus on more of the characterization, which will be a little bit more straightforward, as well as the some of the lesson planning. Okay. And then more clarification on the wafers. We have how do the big discs help with nanotechnology? Are those discs then broken up into the smaller parts? And then, yeah, that's exactly right. So again, it's the top down thing where you have the wafer, and then it gets patterned, and it has all these little different designs, usually some sort of circuitry. And then eventually that gets layered with all these different materials, have different properties to do whatever their device is trying to do. Maybe it's a light sensor to go into a camera, or it's a memory chip to store information for your computer. But eventually it gets processed, it's designed and then processed and created and then chopped up into pieces. And those pieces will then go into the rest of the device or the actual object. So like the camera or the computer or things like that. I hope that explains it a little bit. But with that, I'm going to add, so eventually at the end of this, you don't have to remember all of these little links and things like that on the Google Classroom. It will still live there, but I'll also have a resource page. And that resource page will also have a lot of different pieces of information. And if anyone has gotten a chance to, if you click on some of the activity information at the bottom, there's also additional information like that you can read up on as well, that I sort of recommended for you to look through either before or after, or use as reading material for your students. Okay, and then the sun art activity. Okay, so the sun activity is really just to mimic the same process as the photolithography, where you're using the light, and you're using UV light in the clean room, but then we're using UV light outside, right? And we have the transparency, which then if you draw on the black, it will block the light, but then whatever's clear, the light will go through, right? And so by then you can pattern. Do I still have my paper? Okay. Yeah, then you have your pattern, right? So this would be the mask in the photolithography, and then this would be the wafer. And then ideally, it's not a perfect model, right? But once you have this, then you can actually, draw more things. You could try to deposit more material, because that's what somebody with a wafer would do too. Does that make sense? Okay. All right. And then, I love this. Oops. I love this one too, which is, would colored nail polish work similarly as clear polish? I'm excited to experiment. So you should. I think that's a really nice riff. I guess, spoiler alert, it does not work the same because it is opaque. So when it's opaque, it's not going to have that interaction with the light. The light can't get through the thin film. So I think that's a really nice way to sort of test it out as well. Okay. All right. So that's that. And then I know someone had requested the discussion diamonds. So we'll go through them really quickly. I know it's a little bit after the fact, but I do like that everyone did it. So I want to give you guys props for doing that. So Vicky talked about the space elevator, which I think is a very lofty goal, but just for some background context, this is where someone thought that they could make a space elevator, because it's really energy intensive to send a rocket into space, right? So they thought, oh, well, if we use these carbon nanotubes, which are really strong and really light, we could build this space elevator that's 2 miles high or 3 miles. I don't actually know the distance of space, but very, very high into the atmosphere. So then we could sort of like have this rocket elevator to take you up into space instead of launching. That I don't think has actually happened, but it is kind of interesting to do that, right? And then Leo talked about nanoscale that don't behave the same size, properties, and shape of super adhesion. So maybe the gecko. Did you read about the gecko? Oh, clear
Yes.
polish. Okay, you read about the gecko. So yeah, there was. I think it's also featured in some of the videos. So a lot of the information is sort of churned over and over again, but they have the gecko where it can walk on all different types of surfaces upside down. It's kind of like the Spider-Man, right? And so people are trying to mimic that same type of ability using the gecko as sort of a biomimicry. So yeah, that's great. And then yeah, nanoscale items do not have typical properties. I like that. All right. And then we have this is two groups. So thank you for doing that. So Joanne, it was more like a biomedicine, I think. Everyone did something a little more human related, I'd say. So Joanne talked about non-painful ways to test with blood. It's kind of like they were shrinking the size of the needle smaller and smaller. Because if anyone has done like acupuncture, right? Acupuncture, when you get a needle put into your body, you can hardly feel it. But when you get blood drawn, it hurts quite a lot, right? So there are different sizes of needles. And I think they were trying to optimize for that. Tattooed ink. Oh, for insulin testing. Yep. And then photoreceptors. Oh, so this was more like trying to build artificial eyes. Okay, so actually one person at Stanford, his name is Daniel Palanker, and he did this really cool, he's doing this really cool research project where they're trying to restore sight to the blind. So they're kind of, long story short, they're flipping basically a solar cell because a solar cell takes light and turns it into electricity, whereas an eye kind of does similar things where it takes in light and then it becomes some sort of electrical signal that goes into your brain. So he was trying to model it off of a solar cell, and they've been able to restore sight in humans and I think rabbits. So, and this is just an aside, but when you are doing biological studies, you have to go through all these different animal models, which I think is really interesting. And it's kind of tricky because not all animal models will work the same. So you could start with a mouse, you could start with a bunny, then move up to like a bigger animal, and it may not always translate. So it's kind of an interesting thing where there may be challenges just to get it takes so much work to get a drug or a device to market. Yeah. Okay. And then Portia, she talked about the food industry. Yeah, there are debates on the safety in nanotechnology. It can be harmful, but also useful, really good. Nanobots can't be made yet in the motion of molecules. At that level prevents the controlled motion. Yeah, that's really good. So yeah, all sorts of things when it comes to food. We talk about the microplastics in the ocean. There may be nanoplastics in the ocean. We don't really truly know the impacts of that. It's kind of this thing where, at least personally, I feel like, everyone created the cell phone or the smartphone with the best of intentions, but now we're realizing there are some of these negative drawbacks. And I think any sort of new technology has that, right? Where depending on its use, it could be really great, but it could maybe not be so great as well. So I want to make it clear that nanotechnology, although I'm really selling it to you as a educational platform, I think, there are real problems also at hand. So Amy talked about liposomes. Okay, it was another, I think, food sciencey one with protecting flavor and sensitive vitamins that are added to food. Very good. And then, yeah, the nanobots as well. And actually your makeup, like a lot of your serums that, they store some of the like fresh, I don't even know, the fresh compounds, and then you put them on the skin, and then the liposomes or whatever capsules break on your skin. That is sort of a version of nanotechnology. The liposome is basically encapsulating something, and then will break on your skin and deliver whatever serum or whatever it needs to. And then June worked on the environmental the environment and nanotechnology. So I thought this was also a good one as well. Research into human health, right? The good and the bad things. So, for example, yeah, fullerenes, which is carbon. It's pretty. We would assume is pretty inert, but fullerenes in particular are not very good for people. And then you can use gold and silver nanoparticles to measure the amount of nanopollutants in the environment. Generally, gold and silver are actually pretty okay for the environment. They're inert, pretty inert. Chips in tree to measure health of tree or crops. And then discuss safety of nanoparticles in our life. Okay, yeah, this is a really good one too, right? So asbestos. Asbestos is actually quite nanoscale or microscale, and that obviously, if you breathe it in, it's really bad because it's really sharp. So it will go into your lungs and stick in there. So we obviously don't want that. But again, there is this dichotomy of the good side of nanoscience or nanotechnology and the bad side of nanotechnology. All right. Does anyone have anything to add to this at all?
Hey, Angela, I was just thinking that one area that we're always trying to hit is human impact.
Okay.
So that would be a pretty easy link. Journalism on human impact.
Yeah, and actually tomorrow we're going to have another guest speaker. He's a professor at Arizona State, Jamie Wetmore, and he actually studies the what is it called? Society and ethics of nanotechnology. So we'll go through this really fun activity. I hope it works. It's those cards that you had in your packet. They're kind of long and rectangular, and it's like a farmer from China and like some sort of nanotechnology. You might see it later in your packet. But those are like little character cards and different types of nanotechnology. And it's a really fun thing where we will sort of pretend we're a particular type of person and think about like what is the impact on this particular person, like a farmer in rural China, or a businessman in America. Like what kind of technologies would you need? So I think that's a really good one as well. Mm-hmm. But yeah, okay, awesome. Anyone else? Okay. All right, so we're gonna keep moving. Forward. We're gonna have Dennis, but before we have Dennis, for the first time, I'm running ahead of time. Okay, but I do want to sort of review our nano story then, if we have the time. So I want to talk about what we've been doing so far, right? So we're kind of all the way through to all the content that we're going to discuss over the last couple of days, or we will by the end of today. So, right, nanoscale materials are very small and have unique properties. Because of these properties, there's many different applications. And then day 3, because nanomaterials are so small, we need to use special tools to make and understand them, right? So that's the sort of whole storyline that we have throughout the course. And then eventually, the ask is kind of on you to say, how do we take that information and put it into your classroom? How would we get this to teach to your kids in a digestible and easily understandable format? And so that's something that we can talk about now. We can, what are some concerns? I missed it, but I should have mentioned, there are big concerns on what is our classroom going to look like, right? How are we going to do some of these hands-on activities in a remote setting? And I'll be honest with you, I don't know if I have the best ideas or if I have any sort of answers for you. I guess I have ideas. They may or may not be the best ideas, but I think Leo was showing me. He texted me a photo of some of his packets that he's sending to his students. I think for the fall, it looks like a little mailbox or a post office shop where there's boxes and boxes of materials. But I also know, that depends on your classroom. Maybe you don't have those resources. So I think obviously relying on simulations is a big thing. We're looking to figure out if we can do some of these activities online, but I guess maybe we, in the meantime, we can sort of start talking about more of the remote stuff right now. I'll stop sharing. Yep, go ahead.
Gizmos. I don't know if everybody's been on that platform, but Gizmos is a great,
Gizmos,
great remote learning application. I mean, we adopted it because it's manageable, it's affordable, and it gives access to and equity to all students.
Okay, and I can write this down. Gizmo.
It'd be amazing to see some of the principles of nano, like the lab simulations that you're doing, to be threaded into that platform.
Okay, great.
If you don't have gizmos, Leo, it's like everybody gets like 1 minute a day, though, huh? If you don't have the subscription, 4 minutes
Correct.
a day.
That's correct.
I'm not 100% sure, but I know that our district got it for free when someone from our district went and contacted Gizmos. So I don't know if it's worth reaching out to whoever in your district might be able to talk to Gizmos to get a free account for all your students, because our district got to do that. They only said that we could do it for 6 months through the rest of distance learning, but I'm hoping they extend it. But that might be optimistic, but it's worth just mentioning, I thought.
What is Gizmos?
It's like a more, I feel like it's like a better designed learning environment for middle schoolers and high schoolers, for that kind of like PhET, but just more like I don't know how to explain it. Maybe Leah can explain it a little better, but I feel like it's better structured for a self-paced activity. And I don't know if anyone else wants to add to that.
It's a lot like that, but a lot less jargon, a lot less algorithms, a lot more images, a lot more user friendly.
All right. Well, are there any things to add? Feel free to add them in the chat as well. I can take notes, and I can add them to the resource page that you'll also get later on.